This is Lewis Thomas with another edition of Master Carpenter Series. And what we're going to get into today is the hip roof. And what I'm going to show you is how to do it on paper. Get all your measurements on paper. You see, whether you're designing something, you're designing the roof, whether you are reading blueprints, and you're getting all your measurements off the blueprints, no matter what, you're going to be able to do this. And the method that I'm about to show you is a method that you can use no matter what kind of roof you are doing. And when I say what kind of roof, no matter what kind of hip roof you are doing. And in particular, what I'm going to deal with on this is not the basic hip roof. I'm going to deal with the bastard hip roof, okay? Or the mixed pitch roof, where you have two different pitches coming together. And I'm going to show you how to do that. That's a very popular roof. And so there's a lot of guys have a lot of trouble doing this roof. And the way that I'm about to show you, you're going to be able to do it no matter what type of overhang you have. I don't care if you have a 10-foot overhang. You're going to be able to do this roof. So without further ado, I'm going to show you how to do this. Let's get started. Now, what I'm going to do is I'm going to show you. Now, what I would normally do is I would get a block of wood and do this on the job site. And I can do this on the job site in 30 minutes. I could figure out a hip roof with the commons, the hips, all the rafters, the jack rafters and everything, the angles in 30 minutes. Now, it's going to take me longer to do this than 30 minutes, but let's just get started. Okay. Now, the first thing you want to do, right, is you want to get a nice little triangle going here. Nice little triangle going. You don't want it too big if you're using a piece of paper like this, like an 8.5 by 11 piece of paper. You don't want it too big, all right? Okay, you draw a regular right angle triangle like the first one I did. Then what I do is I get a line going here. Now, all the things that I'm about to show you, all these lines here, they are very key. All right. They kind of drew that one a little too long, but you can still get the point. Because this is a hip roof, the steepest side of the roof, the plate height is going to be higher. And that's what this line represents here. Okay, it represents the steeper side. And the plate height build up. That's what this line represents. Right? So you see here. Now, I'm going to give you this right here is a common, a king common, and this right here is a common, a king common. And this, of course, is the hip. This line right here, the higher line, that represents the buildup for the plate height in which you're going to set your rafters. All right. Now, just a moment. Now what we're going to do is plug in some numbers. Now, when you plug in these numbers, for the span of your building, okay, or the depth of your building, let's say the width of your building, the depth of your building, not the width, but the depth of your building is, let's just say it's 8 feet. All right. Let's just say it's total 8 feet. So what we would do is put 8 feet here. 8 feet. All right. And 8 feet equals 96 inches. Now what you want to do is, and you want to figure out the lowest pitch first. And for this side here, I'm going to make this one kind of difficult. Okay, I want to make this one kind of difficult. We're going to make this one an 812 pitch on this side. On this side, that's an 812 pitch. 812. Okay. 812. And the hypotenuse for 812. 8 squared plus 12 squared equals 14.42. The square root is 1442. Okay. And you can see that you could get the answer for that just looking at a framing square. All right. You see, for 812 pitch, it's 14.42. Okay. That's a pretty common pitch. All right. Now, the next thing that you want to do after you get your run for your shallow side, okay, which is a 812. We're going to make this side here a 1212. So we're going to make this side here a 1212. So we're going to go 12 inches a rise per 12 inches a run. And that comes out to 16.97. All right. So we got that plugged in. We know what this rafter is going to be, what pitch this rafter is going to be on. And we know what side this pitch of this rafter is going to be on, 812 and a 1212. Now what we want to do is, since we know what the pitch is, we're going to take 8 feet, okay, and multiply it by 8 inches so we can see how high the height of the rafter from the top plate all the way up to the side corner of the ridge. All right, the inside corner of the common rafter that's going to hit up against the hip. So let's get that. So we got 8 times 8, we know it's 64. So I'm just going to do it on the calculator. 8 times 8 equals 64. So what our height is 64 inches. That's from this line up to here. Now, I guess at this point, what I should do is show you how the roof is going to come together. All right. When you frame it, let's say, for instance, this right here you got that there, right? And you got a ridge here, all right? And this right here is a common. And this is that 812 side, okay? Now, I only have one side. And so if you're looking down on this, this is how it's going to look. I'm just going to draw it with lines. If you're looking down on this, it's looking like this. All right? This is the 812 side. This represents the 812 common, which is this one. This represents the hip, which is this one. And this one represents the 1212, which is this common here. You see? So Now, what I'm going to do is giving you an example of this, drawing it out with the width of the stocks. So let's say this is another rafter here. All right. This is the 12-12 side. All right. Or that rafter. Or this rafter. All right. And we're just looking down the roof, like if we were hovering above the roof right as it was being framed. And then what you're going to have is on the 12-12 side, you're going to have this. I'm not on the 12-12 side, but on the hip, you're going to have this. All right. So this is your common for the 8-12. Let me put 8-12 here. This is the common for the 12-12 side. 12-12. And this right here is your hip, which we don't know what it's going to be right now. Well, I do know what it's going to be. It's going to be 9.413. Okay. That's about 9 3/8. Okay. And then we put a slash there over 16.97. Okay. So I hope you can get what I'm saying, how all this ties in. I had to do this. Now, what you're seeing here, all you're seeing is 3 rafters. 1, 2, 3. 1, 2, 3. So all I'm doing is I'm really just focusing on in my graph just that corner, and the imaginary lines for the other side, it doesn't matter, because everything on this side is going to be the same thing as these 2 rafters on that side. You see what I'm saying? So that's why I only deal with 1, 2, 3. Because I know when you cut this one and trace it and put it on that side, it's going to fit. Same thing with this hip. In theory, it's supposed to fit. Okay. And it's the same thing. And it's going to be the same thing here. So, but we don't label these sides. And so all I'm doing is working with the key elements, the key parts of the roof. And we could fill this in with an 8-12 on the other side another time. And the hip that goes down, like here for the other side, you just trace this one. So just wanted to give you an idea of what you're looking at. All right. So now that we have our height from the top of the wall plate all the way, and this is one of the reasons why I wanted to draw this, your measurement right to here. Okay. In other words, this line right here, it represents exactly this line, the one that the hip butts right up into. It don't represent this line over here, which is 1.5 inches away from the hip. You see? And on this side, of course, that line represents this line here. Okay. And this line represents an imaginary line that runs right down the center of the hip. It's the long point of the bevel. It's the long point of the bevel of the hip here. Okay. And it stops right there. The way that I figure this, I don't figure this where it runs all the way to here. That's no, that's not how I do it. I figure to the long point of the bevel, which basically intersects with this line, and this line. And so the longest point, that's the longest point. So I just want you to know what all of these lines represent in proximity to the actual framing, so you don't lose your bearings. All right. Now that we got that out the way and we got our height here, 64 inches. Now, a key thing that you want to understand is what kind of overhang you're going to have. What kind of overhang you're going to have. Now, what we're going to do is we're going to do a 16-inch overhang is what we're doing. We're doing the 16-inch overhang. Now, when you're doing, and the reason why I'm doing the 16-inch overhang, I don't want to do a 1 foot overhang because I want to show you something here. Let's do this. And this is where a lot of carpenters get messed up. And this is where I got messed up when I was first learning how to do bastard hip roofs. Now, let's say this right here is, we're going to say this is 1 foot. Okay. And this right here, we're going to say that's 8 inches. Right? That's 8 inches. Okay. Now, I want to show you something here, because when you do your soffit and fascia, everything on both sides of the roof, they have to be the same. They have to, the fascia has to be able to wrap around the corner of the hip and line up with the 12-12 side and be nice and flush with the top. Okay. And so that's what we're going to look at right now. So let's say you have 8-12 and 12-12. We already know that that's 14.42. Okay. Which is 14 3/8. 14.42 hundredths of an inch. Okay. Now you also have 12-12, but guess what? And watch this. I'm going to draw this like it's a subfascia. All right. I want to draw this like it's a subfascia, just so I can give you an illustration of what I'm doing here. Okay. Now, so, and let's just say this is the top of the 8-12 rafter and it's coming down to the subfascia. All right. Now, what we want to do is match this up with the 16, with a 12-12. With a 12-12, what you're going to have is this. Okay. Now this part extends, same thing. It is 12-12. All right. And the angle for that is here. Now, now what you're going to do on your rafter, and I'm going to do a real live shot of this too. I want to make a video with a real live shot of this with me cutting the rafter. And I'm going to be out there showing you all the little technicalities and all that kind of thing. Now, if you have a 12-12 rafter that's running 12 inches, but it's going 12 inches up. All right. So for every foot, you're going up 12 inches, and that's from here to here. This represents the 12-inch rise. OK, from here to here. But the 8-inch rise is here to here. The difference between the 8-12 and the 12-12, that difference there is going to be 4 inches. It's going to be 4 inches different. Now that 4 inches, that lets you know how high you got to build up your wall plate on the 12-12 side. This is a rule of thumb. On the steeper pitch, as a rule, it's always, the plate height is always higher. Okay. The plate height is always higher on a, if all the fascia is lining up. All right. It's always higher unless the overhangs on the 12-12 side is different. You see, that's the only difference there. So let's do this. I hope you understand that. So from here to here, that's the 12-12. From here to here is the 8-12. The difference between the 8-12 and the 12-12 is 4 inches. Because 8 from 12 is 4 inches. So your wall height is going to have to be built 4 inches higher in order for your subfascia to line up on both sides, on the 812 and the 1212 side. However, but if you go with a 16-inch overhang, now you have something a little different. So what I'm going to do is I'm going to draw this out. And this is going to represent 4 more inches. Okay, this is going to represent 4 more inches. All right, from this line to here is 4 more inches. So that means, guess what? If you take this line up for the 16 inches and draw this here and draw this here, now the span, the difference between the 812 and the 1212 is greater than 4 inches because you ran it out 4 more inches longer. So let's look at that. And I want to show you how to do this on the calculator to the best of my ability. I hope you'll be able to see this really clearly. So look at this. Let me clean this screen up a little bit. Maybe this one's a better screen. Let me see. Okay. Hopefully this calculator performs right. But let's look at this. The way that you figure this out is this way. With your, let's say you got your 812 pitch here. So what you do is you divide 8 by 12. And because you're going to make it 16 inches longer, now you multiply that answer. Okay, 8 divided by 12 equals. Okay, now you multiply it times 16 equals. Okay, 8 divided by 12 equals times 16 equals. So that's 10. We're going to write down 10.666. Okay, we're just going to put, I like going 3 decimal points. So we already figured out for the 812. Now this one is going to be very easy because if you're going if it's already 12 inches here, for every foot you're going here is going up the same. So if you go 13 inches this way on a 12-12 pitch, it's going to go 13 inches. So it's going to be 16 inches. So what you do, I guess I should have wrote that one at 10.666 lower so I could put my other number. So now we're going to put 16 inches here. Okay, so he's 6, 6, 6, 6. So look at that. It's 6.666 inches. That's the difference from here to here for the 812 pitch. So yeah, that's the difference in a 812 from a 1212 with a 16-inch overhang. The overhang is what throws off a whole lot of carpenters. It don't matter if you have brick, it don't matter if you have stone. It doesn't matter if you have Dryvit. This is the way that you figure it out. Because if you don't figure this out, when you go up to try to put your commons together and set your ridge, it's not going to end up right. Why? Because you're not going to be taking into account that difference in those two spans.